Hello Tietsu. So we're up to 10.6 similar figures. Page 606 in your textbook. So let's talk about similar figures. If you look through a telescope or a pair of binoculars, you're expecting to see an image that's larger or appear larger than what it is, but you hope to see exactly the same thing as what is there in the distance. The only thing that differs is the size of what you're seeing. And that's exactly what a similar figure is. It's an identical thing, however, the size differs. So similar figures have exactly the same shape, but can be of different size. All the corresponding angles are equal. So if we're looking at these two figures, we can see that E and A corresponds, they're equal, B and F is equal, C and G is equal, and H is equal. All corresponding sides are at the same ratio, which means that if I look at these figures again, the ratio that I will get from E to H over AD should be exactly the same ratio as EF over AB, BG over BC, and GH over CD. So all these ratios of the sides should be identical. Now the ratio of sides is often written as a fraction, shown here at the bottom. It's often called a scale factor. Unless we specify, the scale factor will be written as a number which is bigger than 1, which means I'm always going to pick the big figure over the small figure. In other words, we're always going to pick the big size, so EF over AB. So AB will always be the big one, the small one, and EF, so that we get a fraction that's bigger than 1. And that will be for all cases. It doesn't matter which one I use. If I only use GH, it will be GH over DC, which is CD and GH. So that's how we will use the scale factor. Let's look at an example. Example 9. Identifying corresponding features. For the following pairs of similar figures, and I'm going to be very similar figures, so they already tell me that they are similar. Let's complete these tasks. So number A, list the pair of corresponding sides. Now before I do it, I always find the easiest is to quickly line up corresponding vertices. In other words, I'm going to say, right, let's start at B here, and we're going to say B, this B, look like it's corresponding to F. Then I have the one that's coming into this concave thing, this C. Seems like that's the same as G. Coming down to an end, I have D that corresponds to H over here. And then one more is, let's say, this A corresponds to E there. And when I have colors, it is so much easier to see. So let's quickly list the pair of sides. So I'm going to say in A, let's write with a pen and not the highlighter. It's so much neater. We'll go A, the lists of the pairs. So I'm going to start with the small one, and I'm going to say AB is going the same as, and I'm going to keep it the same order like we have done with congruency. A is the same as E, and B is the same as F. So that's one pair. The next pair will be BC. So it's red and yellow, which is partners with red and yellow, which is F and G. Then we have C and D budding up with G and H, right order. And then our last one, we're going to say that is DA. And DA, which is purple-green, is the same as purple-green, which is HE. Alright, nice, straightforward, no hassles. They ask us now to list the pairs of corresponding angles. List the pairs of corresponding angles. Now corresponding angles is basically it's the vertex, but it's the inside of the vertex, which we can only call angle. And let's start with the green. I'm going to say angle A corresponds to another green one as angle E. Now I'm going to say angle B. So if I talk about vertices, then it's only B. If I talk about the angle on the inside, I have to use my angle sign and not just B. So that is how you distinguish between those two. So angle B, the red one, is butting up with F. Then angle C butting up with angle G. And then lastly we have angle angle D with angle H. Okay. Let's just see. Find the scale factor. Now we said the scale factor, we always are going to use the scale factor. We're always going to use the scale factor as the big one over the small one. Let's write that. Big over small. Right, so the big over the small. Now I'm going to do something very naughty. Don't tell your parents or your maths teachers. But I'm going to write next to each other because I'm running out of space. So what I really need is I need to find one of the sides of which I have the big side and the small side. In other words, one of these pairs that we have, A, B, E, F, B, C, and F, G, one of these pairs where I have both values. I can't use AB because we don't have the value of AB. I can't use GH because GH doesn't have a value. So I have to find one of them which have both values. And it seems like the only one I have is AD and EH. Can you see the green, purple, both of them have values which I then can insert into my equation. So that's exactly what I'm going to do. I'm going to say for the big triangle, I'm going to say EH over AD. EH over AD equals, and that's going to be 6 over 2. Now 6 over 2 equals 3. Now what does that mean? What does scale factor of 3 really means then? What it says that this figure is 3 times as big as this one in all respects, except the angles are the same. Okay, so find the scale factor. We just did that. Now for the last question, and maybe I'm going to jump for D. I'm going to jump with D up to do D over here so that we can do it properly. Okay, so for D, they say find the values of the pronumerals. And now you just have to make sure that you find all of them. Now the smallest number is A, so I can say A equals 50. A equals, let's fix that up quickly. Okay, so I'm going to say D, A equals 50 degrees. Oh, come on, equals 50 degrees. Don't have to say any reason because you can see that they are corresponding. Okay, what other pronumerals are there? There's X. Let's find X. Now what I'm going to do is I'm going to use my scale ratio in this case. We know that X equals the scale factor times 3. Or what am I talking about? The scale factor is 3, which means that if I want to calculate X, then I can say that X is 3 times the yellow purple is 3 times as big as the yellow purple. That's what the scale factor tells us. So I'm going to multiply it with 3. So I'm going to say X equals 3 times 1, which equals 3. Y, now Y is in the small one, which means that its scale factor is, the scale factor is 3 times, so AB is 3 times smaller than 6. So I can say Y will equal 6 divided by the scale factor of 3. And 6 divided by 3 equals 2. Okay, that is the basics. I'm not too crazy. I'll show you another way when we come to triangles in the next chapter. Question, example 10. Decide if shapes are similar. Decide if these shapes are similar by considering corresponding angles and the ratio of sides. Now what I'm going to do is, first of all, in part A, which is the two rectangles, I first have to identify which ones are corresponding, which sides are corresponding. Now if I look at this one, this is the long side and this is the short side. This is the long side and this is the short side. So I'm going to say this is my long side and this is my long side. This is my short side and that is my short side. Now the first thing that we need to look at before we even start looking at ratios, for it to be similar, all angles must be the same. So I can say all corresponding angles are equal. Angles are equal. And I can see that because all of them are 90 degrees. Second of all, are the ratios correct? So what I'm going to do is I'm going to say angle, and because it's a rectangle, it doesn't really matter which order it is, but remember we're going to use the big one over the small one. Okay, so I'm just going to take in the green side first. So I'm going to say GH, GH over AB, or AB equals, I'm going to say that's 7 over 3. Then I'm going to say the yellow one, which is HE, the big one first, HE over BC equals 14 over 7, which equals 2. This equals 2.33 repetitive, right? And therefore I can see these two are not the same, so they are not similar. They are not in the same. They're the same ratio. They're not in the same ratio. Let's just spell similar correctly before I get a hiding from some English teacher. Right, not similar. At the second part, I'm going to do exactly the same. Because I have two equilateral triangles, I don't have to say they are. I can immediately say all angles are the same. All angles are equal. And then if all angles are equal, then the sides, always the bigger one first, so AB over anyone, DE is the same as AC over FD, is the same as BC over EF, is all the same as 5 over 2, and therefore this are similar triangles. Okay, I'm going to get you now to do exercise 10F. Do the following questions, please. So, if you do it at home, 2, 3 to 5, column 1 at home, and then if you come to class 6 to 9, 10 and 12. Now, as they say in Sarajevo, Spoglom.